Blobner per la presentazione dell'Istituto Fraunhofer.
Thank you very much. I have to speak in English because I don't speak any Italian. I had like 5 years of Latin in school, but it won't help me here. So I'm happy that I'm able to present here at this forum what we are doing at the Fraunhofer IFF in the scope of Industry 4.0. I hope that you can get some impression of what we're doing together with companies at the Fraunhofer IFF. The IFF basically stands for Factory Operation and Automation, so we are very much close to the factory, to the shop floor in the processes and the products that we are doing. But first of all, I want to give just a very brief introduction of where I'm coming from in a larger scale. So the Fraunhofer IFF is part of the Fraunhofer Gesellschaft, and the Fraunhofer Gesellschaft is the biggest applied research organization in Europe. We have about 70 different institutes, or more than 70 different institutes all over Germany, and I'm specifically coming from here. So this is Magdeburg, this is where my institute is located, and you can see that all over Germany there are different institutes with different specializations. There are a number of institutes dealing with production matters, but there are others dealing with microelectronics, ICT, life sciences, pharma, and other engineering tasks. So it's a very diverse research organization. And what is important to note is that we have a very large financial volume for our research, but it is important to note that 70% of this money that we are using, really we have to work for the money. So it's based on competitive research that we are doing either through public research calls from the German government or from the EU, but also directly with companies. So companies also pay us to do research, and small and medium-sized enterprises are a specific customer for us. So Fraunhofer, when it was founded in 1949, was really imagined to support the small and medium-sized sector in Germany, because especially the small and medium-sized sector, they often don't have the resources, the competences, and also structure to really carry out research, and this is where Fraunhofer finds its position in the research landscape. So really for the benefit of companies. The Fraunhofer IFF, like I said, we are coming from Magdeburg. We are around 190 employees working with around 20 million euros of research budget per year. And you can see also here that a large share of this research comes directly from industry sources, and another larger share also from public research, but the main focus is really on the industry. We can also see that we've been active on basically every continent on the world except for Antarctica, but as a production-oriented institute, there are not so many customers in Antarctica for us. So, but in every other continent we've been active, and we also have a project office in Bangkok in Thailand as kind of a bridgehead to the Asian market, also into China, where we are also active. The Institute's specializations, research specializations, really focus on what makes a company, what makes a factory, and we have specializations, research competences in our institute that basically mirror competences that are needed in a factory. So we have robotics and automation, measurement and testing, process engineering, logistics, and assistance systems, and we are working on these fields of research, trying to really work on supporting systems and process optimization within these 4 areas. And today I want to really focus on the system of smart, or on the research field of smart work systems, where our focus is really on how to integrate human operators better in an ever-increasing automated working environment. So our focus on automation is really not like bring all the robots you have into your production and keep the humans out, but really like how can we support human operators through automation, through cognitive assistance or physical assistance systems to do their work better. So the human element in production is still one of our main driving factors. And within Industry 4.0, our approach is about using digital data, using data in itself consistently throughout the life cycle of a production system, of a factory, of a machine, and really enable companies and to really benefit from the use of digital data. And as you saw from our competences in our institute, we really don't like just focus on automation and really do automation very deeply, but we work on the interfaces between these different competences. And that's why our core competence really also is in describing the interfaces between the different competences, describing how data can be used at different stages of the life cycle, meaning to use data at the beginning when you're producing, when you're planning a production system, do it fully automatically, do it in a digital way, and then use the data also for testing, for documentation, for job preparation, and always use the same data augmented with data from the next steps, and then you can also use it in the operation of a system. And I know this sounds rather fanciful and theoretic, but we also have the projects that can underline this philosophy. So one of our flagship projects in this respect is a project that we did together with the Lanxess company. Lanxess is a former Bayer company, and they are producing water filtration systems near Magdeburg, between Magdeburg and Leipzig. And what they are doing is that they have very innovative products, and they also came to us with one request that was really informed by their market position. So they came to us and said, look guys, we don't have any product yet, but we need the machine to build the product as fast as possible so that we can go on the market with the product as fast as possible. So can you do, or can you build the machine for us that builds basically our product that we don't know all the properties of? And we promised them, yes, we can do that using a fully virtual system, a fully virtual development process in describing what the system looks like, what it is supposed to do, and basically build a virtual prototype of the machine. And every time the company was one step further with their product development process, we incorporated the data that they just produced and augmented our model with the new data that we had, so that we had a parallel development of the product and the machine building the product for the company. So, and you can see here, our first project in this respect was already in 2011. So this was when the discussion about Industry 4.0 basically was just starting in Germany. We were already producing machines that were basically Industry 4.0 ready. And just last year, we developed built the third generation of this machine for the company. So it's a very successful collaboration with Lanxess and an ongoing collaboration. So, and what this development process allowed us to do is basically build a machine that is Industry 4.0, and we developed a digital twin, a virtual twin of the machine through also incorporating very specific sensors and actuators and electric drives into the system that can consistently feed data from the actual production system back into the virtual system, so that we can use the virtual system, for example, for simulating production runs, for simulating lead times, and also in maintenance, for example, do predictive maintenance on the machine, and also providing assistance systems. You can see something like this here, assistance systems for the operators of the machine where they have all the necessary data from the machines to work on the machine, like for example on servicing and maintenance. So this example was something where we built basically a machine from scratch and had all the degrees of freedom to develop this machine. But here, for example, is another project that we did with a company that was a company that had like a manual work process just before an automated work process. So here the operator had to build a set of tools onto a platform, and this then was further worked on by an automated system. So and here we provided the company with an augmented reality system that basically had cameras on top of the workplace, which provided a live feed onto a monitor for the operator, and then we used the CAD designs from the original planning and provided an augmented reality overlay for the operator. And this helped the company to really cut down on the process time, on the process costs. It especially also provided increased process reliability towards zero defect manufacturing, because in the old times the operator basically had like a sheet of paper next to him, and he had to flip through the paper and see how to assemble these parts on the platform. And of course he had to imagine like 2D printout into a 3D environment, and mistakes were made. The process was not zero defect liable, and this solution really helped the company to improve these processes. So here we used established processes and still used available digital data to improve the processes. Another thing that we also did on an existing process is here for a company which built wheels or rims for cars, and they had a problem that that with the degradation of the drill during the process, the holes that they were drilling became uneven. So, and they asked us if we could find a solution to basically do a predictive maintenance, a predictive production planning on their system, so that they had a consistent quality in their process. So we had to find a way to bring together the process data with the quality data and do a predictive production planning for them, so that they can really improve or ensure the consistency of quality of product throughout the production run. So by, for example, slowing down the drill to improve the degradation, and so on and so on. So here we also incorporated existing systems, used some new sensor systems, especially then also big data analytics to really understand how the process is working and how it's connected with the quality. I said that we also do projects in robotics and automation, and one of our main focuses here is really the safe human-robot collaboration. So really ensuring the safety of humans when they are operating with robotic assistance. So we are not talking about something like a welding robot in a car factory. This kind of robot will always be in or behind a fence, but we're talking here about automation within highly customized industries. This project here, for example, was together with KUKA and Airbus. And Airbus is really, or the aeronautics industry is basically a lot size one production environment. And automation is nearly impossible because every time a part is different. And so if we are able to incorporate automation into aeronautics, this would be a big step. And we try to provide this with, or we provided this with a mobile robotic platform here, which supported human operators in aeronautics. We have a very strong cooperation with KUKA, but as you can see in the background, we work together with all major robotics manufacturers. You can see Fanuc and ABB robots also in the background. So there we are really working together with all the major manufacturers, but also based on the requirements of what our customers need. A last project I want to present is in telematics, using GPS data, using product data for storage optimization. And here we have an example of a company producing wind turbines located in Magdeburg. It's called Enercon. And they basically had the problem of finding the turbine blades on their lot. So because you have to know that every turbine is custom manufactured to every blade is custom manufactured to a specific turbine. So when the production production process comes to a specific step, they need a specific part. And they really had the problem to finding these specific blades on their lot because they had their forklift drivers putting them where there was space on the lot, basically. And when the forklift driver was sick, nobody knew where the blade basically was. And what we worked together with the company to establish is an improvement of the production process. So we used RFID embedded within the blades and married those to external GPS units so that they were able to find each and every blade on their lot, no matter where it was. We also provided them with the warehousing software. So it's not just the hardware implementation, but also the software implementation that we provided for the company. And it's still used very successfully, and there have been multiple iterations also with this project. And it's an ongoing cooperation with them, also trying to connect other production resources like cranes and stuff, and further increase basically the transparency of the production process for the company. So these projects should have given you like a short impression of what we are doing. Of course, we are doing more, but it's very hard to really pack it in this presentation. So, but basically everything that we do kind of fits into this fourth industrial revolution context, and we are working, as you saw, basically on the digitalization of systems, of individual processes, and of infrastructure. And for each, we have specific projects that can show and supply references of how we can interact and better use digital data, connect digital data to increase process transparency, to increase process quality and combine it with quality, and basically make a company work better with the available resources that they have. So with this, I want to end.